Hi everyone, you're welcome to Best Science Brain YouTube channel once more. Today we are looking at solution to the May-June 2024 chemistry practical examination that were written today. So we're looking at the real questions and their solutions. So this exercise or this video will serve as a kind of revision for students that wrote this examination for them to know how they performed in the examination, and if they didn't perform so well, they can prepare for the theory. There is still hope for them to credit this paper by doing very well in their theoretical examination. So this is practical chemistry alternative A. This video also will serve as a reference for those who want to write alternative B practical, because they may still have similar questions just like alternative A. And for those who are going to also write NACO examination in June 2024, July 2024. Now, let's look at the question. Before we go ahead, if you're not subscribed to the channel, kindly move down to the channel's name as the video is playing, Best Science Brain. Tap on the channel's name on the subscription button or bell only once under the channel's name and get subscribed to the channel. So what I would say you should subscribe to the channel is that whenever we do videos or we do practical or theoretical teaching, if there's anything we have to say or any comment or review we have to make, we'll make it inside the comment section of the video, so that if you're a subscriber, you'll be seeing the comments and follow us. You shouldn't be one that should be jumping into a channel and jumping out. So it costs you nothing to subscribe. Just tap the button and get subscribed and follow us as we learn science in both at O level, A level, high institution, postgraduate, master degree for students in tertiary institutions, and for those at O level as to build a future generation. Now let's look at this question. May-June 2024 chemistry. Say all your bullet readings, initial and final, as well as the size of your pipette, must be recorded, but no account of experimental procedure is required. All calculations must be done in this booklet. Number 1, A is the solution of potassium tetraoxomanganate 7 containing 0.020 mole per dn³. B is the solution of iron 2 obtained by dissolving 3.8 gram of iron granules in 250 cn³ of solution. I repeat, A is the solution of KMnO4 containing 0.020 mole per dn³, full stop. B is the solution of iron 2 obtained by dissolving 3.8 grams of iron granules in 250 cn³ of solution. Put A into the burette. In the burette, pipette 20 or 25 cn³ of B into a conical flask and add 10 cn³ of H2SO4. Titrate it with A. Repeat the titration to obtain concordant titer values. Tabulate your results and calculate the average volume of A used. So let's go to the result. So this is the specimen solution of table we have here, a sample we have here for that titration. Bullet readings, cn³ must be there. Rough, 1, 2. You can still do it to 3 times or only 2 times. Final reading, under rough 13.40, under first one 26.50, second 39.60. Initial reading, under rough 0.00, under first 13.40, under 2, 26.50. Then volume of AUs, we get it by subtracting 13.40 minus 0, giving us 13.40. 26.50 minus 13.40 gives us 13.50. 39.60 minus 26.50 gives us 13.10. Now, finding our VA, we now have to choose 1 and 2 because the rough is far. The difference between the rough and 1 and 2 is more than 0.2. So when you want to choose your theta values for averaging, the difference between the theta values should be not more or less than 0.20. That is the limit of accuracy for choosing theta for averaging. So 13.4 is far off. So we have to choose 13.10 and 13.10 and divide it by 2. Since we use only 2, that gives us 13.10. We are not saying that this is the accurate endpoint. In May June examination, the endpoint depends on the teacher. So the teacher provides the endpoint that will be used to judge each student in any given school. So that we have 13.10 here does not mean that your teacher, as a student here watching this video, should use 13.10. Your teacher can use 3.50, can use 5.50, can use 10.00, or can use any value, provided that value will not lead you to error in calculations. So that is right for that teacher. Because another one of the questions they ask here is to find percentage of iron 2 in an iron sample. So maybe if your endpoint is very wide, it can lead you to get a high concentration of B. And if you have a high amount of CB, maybe the percentage of iron will lead to a negative, will be a value higher than 100%, which is the wrong answer. So when we did the live practical, we got the low endpoint, and we know what we said in this channel, that the low endpoint, you don't expect to get the theoretical endpoint of 18.10 when you do the live practical, because when you expose iron 2, when you're doing those reaction, as long as iron is exposed to oxygen, you're going to undergo instant oxidation. Some of the iron 2 will change to iron 3 without waste of time. It's an instant reaction. So you don't expect to get 18.10 in the real practical. But if you give your students 18.10 at endpoint or 18.00 at endpoint, provided that is what you reported on your report sheet, your students are not wrong. They will see get it right. So that is it. So students should not be afraid of endpoint. So as long as it agrees with what the teacher recorded, it must not be the one I'm using here. Because what I'm using here is not even, it's just what I guess. We use it for the table. It's not actually what we got in the experiment to watch our video. So that is it. Then, for how do they mark the table? The table is 8 marks. 8 marks, provided that your endpoint lies within your teacher's your limit. That is, if your endpoint should be plus or minus 0.10 of their teacher's endpoint. Plus or minus 0.10 of your teacher's endpoint. For instance, if your teacher's endpoint is 13.10, as you have here, so your VA should be either 13.00, 13.10, or 13.20 for you to get the maximum 8 marks on the table. If your teacher chose 15.00 as his endpoint, then your VA well calculated should be either 15.90, 15.00, or 15.10. If your teacher chose 18.00 at his endpoint, your VA should lie within the range of 17.90, 18.00, or 18.10 to get maximum 8 points. How do they mark this kind of table? They mark 1, the first title, 4 marks. Second title, 4 marks, giving you 8 marks. Even if you like, do the experiment 3 times, 1, 2, and 3. They only mark 2 out of the 3 that agree with the teacher's endpoint. But what if your endpoint differs by 0.20, that is of your teacher's endpoint, not 0.1? You will not get 8 marks on the table, you get 6 marks from the table. 6 over 8 now. If your endpoint differs by 0.3 of your teacher's endpoint, maybe your teacher got 17.00 and you're getting maybe 16.70 or 17.30, 0.3 difference, you get 4 marks from the table, that is 2 over 8. Now, what if your endpoint differs by 0.4 of the teacher's value? You get 2 marks on the table. What if your endpoint differ by 0.5 value of your teacher's endpoint, either above by 0.5 or below by 0.5? You get only 1/8, 1 mark on the table. What if your endpoint differs by more than 0.5 value of your teacher's endpoint? You score 0 on the table. You score 0 on the table. But the averaging is 2 marks. Finding VA is 2 marks. So whether your endpoint is in agreement with your teacher's endpoint or not, if you do your averaging with concordant values are values that do not differ by more than 0.2 from your table, you get 2 marks for finding VA. That means everything about the experiment is 10 marks. 10 marks. Now, after they mark this, they now look at there are other things that you can do to lose other marks from the table. Look at the bullet reading. You have CN cube there. Is there no unit on the table? You lose -1 for this CN cube you didn't put there. You don't have to put CN cube all through the columns. No. Once it appears only once, you score. I didn't say CM. CM is length. I didn't say CN squared. I didn't say liters or DM cube. I said CN cube. When it appears once, you don't lose mark. But if you don't write it or write a wrong unit, -1 goes off. Then, if you did not put these readings to 2 decimal places, all these readings, you can see them on 2 decimal places. Any error, you lose -1. If you do it 2 times, -2. You see that. Then, if you write it with pencil, you lose also -2. So all this, if you look at the instruction, you write in ink. Ink means either blue or black ink. You lose -2 for not writing in ink if you use pencil. Now, assuming that you're building your table, maybe this is the teacher's endpoint, 13.10, and you are building it and you're getting 15.40. 15.40, that is a value different from your teacher's endpoint. You cancel it and build a new one to agree with this value, which you have here with your teacher's endpoint. If you're getting the wrong value before, it's obvious there, and you cancel it to build a new one to agree with your teacher's endpoint. You lose -4 from the table. That is, you lose half of the mark allotted for the table. So that is how this is being marked. So you have to know all this for those who are writing on TDB or writing NECO, the same marking scheme follows. So we'll go to the next question. Question B says, from your result and information provided, calculate I concentration of B in mole per dm cube. Calculate I concentration of B in mole per dm cube. What is B? They say that B is a iron 2 solution obtained by dissolving 3.8 grams of iron granules in 250 cm cube of solution. So when we did our live video, we had a comment from a teacher that says that he was just trying to say that the calculations should be at the same. The values given to us will be at the same as provided in the instruction. We told him that it can be possible. So that WAEC is technical. That the values they give you in instruction may not be the same as what they're going to provide in the question paper. These experiments have been done. So don't just calculate or teach students based on theoretical that it is the way it's supposed to be. It's in the instruction that the concentration is going to be like this. When you calculate concentration of CA, you're going to have a 0.01. And CB, you're going to have 0.036 something. That is wrong. You should be well experienced and well guided to teach students very well, because concentrations are changed. You look at it, and we said it in the comment section. We also said it in the video. So if you look at even the solution, the B is no longer, they not even tell you that it's a hydrous ion to ferrous sulfate. They say it's ion 2. They change B and even change they get the mass of ion. So they change the B sample that they gave in the instruction to a different thing altogether. So you have to be well guided. You don't tell students, or you just come and just say maybe you're new in the teaching field. You're basking the euphoria of being a chemist teacher or whatever you call yourself. So you have to be well guided and then know that you don't expect WAEC to ask you verbatim the same question as you have in the instruction. Things can be twisted. This is an examination. WAEC knows the concentration what they give to you. They twist it this is the examination that have been evaluated experimentally and theoretically, and then they know actually this is the kind of thing you're going to get when the student is going to get when they calculate it. So they have to balance things. So you don't expect them to give you exactly the same thing, the same concentration as you have in the instruction, as we rightly pointed out in our video. So we'll now go to the question again. The question will be in mole per DNQ. Let's go to the solution. Question 1bi. To find CB, our CA given to us as 0.020 mole per DNQ. Our CB is unknown. You can see the question mark there. And Na is the number of moles of the permanganate ion, which is 1 in the balance equation. Our VA from our table is 13.10. As a student or teacher, your VA will vary, so you don't expect the answers to be the same. And our VB, that error, so error corrected. Our VB is 25.00 Cn cube, and MB is the number of moles of ion 2 in the equation, which is 5 moles. We're looking for CB. We applied the overall titration formula CAVA over CBVB equal to N over MB. We made CB the subject. CB becomes CAVA MB all over VB times NA. We now make substitution using the values given to you in the equation. CA is 0.02, VA is 13.10. We are using 30 as our endpoint. You substitute with your own endpoint and check your answer. Then our NB is 5 all over 25 times 1. So in this substitution, the only thing that can vary there is 13.10. That is your VA. And also VB. If your school is using 20 Cn cube as VB, then you have 30 Cn cube here. If your school is 25 Cn cube, then 25 Cn cube is what you have there. So solving out, we'll have 0.054524 mole per DNQ. This is the value of our CB based on using 13.10 at the end point. So if you're using 10 Cn at the end point, replace 13.10 with 10 and find your answer. If you're using 18 as the endpoint, replace VA with 18. If you're using 3.5 as the endpoint, replace VA as 3.5. And then make your calculation to get your CB. We'll go to the next question. II says concentration of B in gram per dn cube. Concentration of B in gram per dn cube. So let's go. Solution. Let's remember that B is the solution of ion 2. Solution of ion 2. So the concentration in gram per dn cube is given by concentration of B, that is in mole per dn cube, times the atomic mass of ion. The atomic mass of ion. So making substitution, our CB is 0.0524. The atomic mass of ion is 56, and that gives us 2.93 gram per dn cube. You don't go and use the molar mass of iron sulfate here because the question did not mention iron sulfate. You don't assume that the instructions say that it's iron sulfate and you guys start using iron sulfate. You have to read the question and digest it very well. So they say that B contains B is the solution of ion 2 obtained by dissolving 3.8 gram of iron granules in 250 Cn cube of solution. So that ion is what you're using there, the atomic mass of ion, which is given to you in bracket as 56. Nobody gave you the mass number of FeSO4. Either did they give you atomic mass of sulfur or C inside the bracket. So the question of the B in gram per dn cube is 2.93 gram per dn cube. So in your own solution, use what you got as CB in question I and then multiply it by 56. That becomes your concentration of B in gram per dn cube. Number 3 question says mass of ion 2 ion in 250 Cn cube of B. Mass of ion 2 ion in 250 Cn cube of B. So let's see how it goes. For our question 2, the concentration of ion 2, or that ion 2 is solution B, you should know that in gram per dn cube is 2.93 gram per dn cube. And then going to question 3, mass of ion 2 in 1 dn cube is 2.93 gram. That means of that 2.9 gram per dn cube. That is, you have 2.93 gram of ion 2 in 1 dn cube. So we'll now move and say 1 DN cube, which is centered as 1000 CN cube. Or solution B contains 2.9 gram, 93 gram. We're looking for the mass in 250 CN cube. So that'll be by proportion. Therefore, 250 CN cube of solution B will now contain 250 times 2.93 over 1000. And that will give you 0.733 gram. 0.733 gram. Remember, your answer is based on what you got. The value of your CB will affect every other value you are getting here. So replace where is appropriately, replace your CB for question 2, replace CB with 0.0524 with your own CB and multiply 56, and then follow the same process to solve this number 3. So the mass of iron 2 here is 0.733 grams to 3 significant figures. All calculations will be provided into 3SF. That is chemistry practical for you. Not 3 decimal places, please. Question IV says percentage of iron 2 in the granules. Percentage of iron 2 in the granules. So question IV, percentage of iron 2 is given by mass of iron 2 all over mass of iron granules times 100 over 1. Mass of iron 2 is the one you got in question III, which is 0.733 gram. Remember that this is the mass in 250 CN cube. Now put it down there. The mass of iron granules, in the question you're told that we have 3.8 grams of iron granules in the same 250 CN cube. So when we're dividing masses, we have to make sure that the masses we're using are masses in the same volume. So we have 0.733 grams of, you see that WAEC is technical. They know they're going to ask you the percentage of iron 2 in question 4. That's why they ask to find the mass of iron 2 in 250 CN cube, which is 0.733 from our own information here. Then the percentage of iron 2, in the question instead, they gave you the mass of iron granules in the same 250 CN cube. You see, we are now talking about equating masses in the same kind of volume, same unequal volumes. So now have 0.733 over 3.8 times 100 over 1. That will give us 19.3%. So the solutions or the answers you're going to get here is based on what you got as your VA. It will still affect everything, but you follow the same procedure. You follow the same procedure, whether your VA is high or low, and your procedure is correct, you get maximum mark for all these problems. Even though the values you get as the answer be different from these values you have here, but they're the right steps and the right formula you should follow to get your answers. We'll now go to question number 2. Instruction reads, credit to be given for strict adherence to the instructions for observations precisely recorded and for accurate inferences. All tests, observations, and inference must be clearly entered in this booklet in ink at the time they are made. We'll now go to the number 2 question. C is a mixture of 2 simple inorganic salts, one of which is a sodium salt. Perform the following exercises on C. Record your observations and observations and identify any gas or gases involved. State the conclusions you draw from the results of each test. So in this question, we can see that C contains 2 simple inorganic salts, one of which is a sodium salt. And from your knowledge of chemistry, common salts of sodium are soluble in water. There's also another second salt inside C. The name of that salt was hidden from us. We don't know all about it. Even though you may have an idea that the second salt is lead nitrate, the 2 of them are soluble salts, but you have to keep silent over it because the solutions are answered logically. You don't have to say, yeah, you know that it's a soluble salt or this is going to happen, because they did not tell you that C is a mixture of 2 soluble salts. Rather, they say it's a mixture of two simple salts. So when we do that video, under the highlight or comment section, we'll have to highlight and review everything. The difference between when they say that C is a mixture of two salts and when they say that C is a mixture of two soluble salts. So let's go to the question now. Question A says, put all of C in a test tube and add about 10 cNq of distilled water and shake. Filter the mixture and keep both residue and the filtrate. So let's repeat it. Put all of C into a test tube and add 10 cNq of distilled water and shake. Filter the mixture and keep both residue and the filtrate. So let's go to the solution. Report 2A. C plus 10 cN³ of distilled water, shaken and filtered. Observation. C partly dissolved in water. Filtrate is colorless. Residue is white. Inference. C is a mixture of soluble and insoluble salts. Yes, we know that the components of C are soluble salts, but since the question did not tell us that they are soluble salts, we have to just pretend that we don't know whether they are soluble or not and report what we are seeing physically. Question BI says, put about 2 cNq of the filtrate into a boiling tube and heat strongly. Put about 2 cNq of the filtrate into a boiling tube and heat strongly. So let's go to the solution. B. Filtrate plus heat. Observation. Filtrate boils, liberating a colorless, odorless gas, which had no effect on litmus paper or peppers. Gas rekindled glowing splint. Inference. Gas is oxygen. Remember or mind you that the filtrate is sodium triosonitrate 5. And when you heat sodium nitrate 5, you're going to decompose, give you sodium diosonitrate 3 and oxygen gas. With difficulty, you have to heat it for a very long time. That's what they say, heat strongly. That's what the question commands. BII says, put half of the residue into a test tube and add dilute HCl. Put half of the residue into a test tube and add dilute HCl. So let's go to the result. II, residue plus dilute HCl. Observation, brisk effervescence, a colorless, odorless gas, which turns moist blue newspaper faint red and lime water milk evolved. Brisk effervescence, a colorless, odorless gas, which turned moist blue litmus paper faint red and lime water milk evolved. Then, inference, gas is CO2, then triosocarbonyl ion confirmed. Gas is CO2, then carbonate ion confirmed. Go to the next question. Then BIII says, to about 2 cNq of the clear solution from II, add aqueous sodium hydroxide in drops and then in excess to about 2 cNq solution from II. II is the one you added the residue and HCl. Add some hydroxide in drops and then in excess. Go to the solution for III. III. 2 cNq solution from 2BII plus NaOH aqueous in drops. Then observation, white in bracket, chalky precipitate formed. Inference, lead-2 ion or calcium-2 ion present. Then next, plus 1 hydroxide in excess. We now have white or chalky precipitate dissolved to give a colorless or clear solution. Then inference, lead-2 ion present. Calcium removed now. Then question IV says, to another 2 cNq of the clear solution from II, add aqueous ammonia in dross, then in excess. To another 2 cn cube of the clear solution from 2BII, add aqueous ammonia in dross and then in excess. Let's go to the solution. You now have IV. 2 cn cube solution from 2BII plus aqueous ammonia in drops. Observation: white in bracket chalky precipitate formed. Lead 2 ion present. We don't bring in calcium here because calcium doesn't react with ammonia. Then plus aqueous ammonia in excess. Observation: white in bracket chalky precipitate remained insoluble. Lead 2 ion confirmed. You see that. We know that lead and aluminium ion, they do not dissolve in aqueous ammonia. But aluminium was not put in the inference because of what? Because the white we observe is chalky, not gelatinous. That's why aluminium was removed. We'll now go to question 3A. Mention gases. Two gases. Mention 2 gases that are soluble in water. Mention 2 gases that are soluble in water. So you can see the solution: hydrogen chloride gas and ammonia gas. In chemistry practical, when you're asked to mention or list, you have to write the full name of the substance. So somebody writing HCl gas and NH3 gas will not score. Somebody writing the formula of these gases will not score. Mention in code marking or coordination means give the full name. Hydrogen chloride gas. It's still not good to write the hydrogen chloride. Hydrogen chloride can exist as an acid. So you must mention gas at the end of it, end of a chloride. It's still not good to write ammonia, because ammonia can also exist as a liquid, aqueous ammonia. So you have to mention ammonia gas. So each of them are very soluble. The two are very soluble in water. Somebody can say mention sulfur oxide. There are soluble gases in water. 3B says, name 2 apparatus that could be used to measure 9.50 cn cube of a solution accurately. Name 2 apparatus that could be used to measure 9.50 cn cube of a solution accurately. So let's go to the solution. So 3B, the answers are graduated measuring cylinder and then burette. Graduated measuring cylinder and burette. Please not pipette. You cannot use pipette to measure 9.50 cn cube. What pipette delivers is only 20 or 25 cn cube of a solution. 3C says, what the use of fume cupboard in the laboratory? What the use of a fume cupboard in the laboratory? Solution. It is used to prevent laboratory users from inhaling toxic gases generated during experiment or gas preparation. Used to prevent laboratory users from inhaling toxic gases generated during experiment or gas preparation. Gases like chlorine, hydrogen sulfide, and carbon 2 oxide are very toxic. So they're prepared in the fume cupboard, or when they are emitted during some chemical reaction, the fume cupboard. That very charcoal in the fume cupboard absorb them and prevent them from coming out to the environment or from being toxic to people in the laboratory. So that is it. 3D says, name 3 personal protective equipments that are used in the laboratory. Name 3 personal protective equipments that are used in the laboratory. The solutions include laboratory coat or laboratory suit, hand gloves, and safety goggles. Laboratory coat, hand gloves, and safety goggles. So we have come to the end of May-June 2024 solution to live questions. May-June 2024 WAEC examination, alternative A, chemistry. So stay connected as we run the live practicals for alternative B. chemistry, and be mindful that the physics alternative A physics experiment on fluid mechanics or OPTROS has been uploaded in this channel, while we will see ways to do other practical physics experiments meant for this year's WAEC examination. Stay connected as we continue to give you more in academics. Thank you very much.